In 2023, a lawyer named Stephen Schwartz submitted a legal brief to a federal court in New York containing 6 case citations. Precedents, docket numbers, judicial opinions, the works. The opposing counsel couldn't find any of them. That's because none of them existed. Schwartz had used ChatGPT to help research the brief, and the AI had invented every single case from scratch, complete with fake judges, fake dates, and fake rulings that sounded completely real. The judge fined him $11,500. But here's the part that should actually unsettle you. Schwartz asked ChatGPT afterward whether the cases were real. The AI said yes, confidently, repeatedly, even when pressed. It wasn't lying. It genuinely could not tell the difference between what it knew and what it had fabricated. That distinction matters more than almost anything else happening in artificial intelligence right now. The AI industry collectively generates somewhere north of $500 billion in annual economic activity as of 2026, and it is built on a foundation that still cracks in ways nobody has fully solved. We are not talking about edge cases or rare bugs. Google's own internal testing in 2023 found that Bard, its flagship AI, hallucinated in roughly 23% of responses to factual queries. Microsoft's early Copilot deployments produced errors in legal, medical, and financial summaries that required entire compliance teams to be rebuilt around AI output verification. The consulting firm Gartner estimated in late 2024 that AI hallucinations cost enterprises globally around $92 billion annually in error correction, liability exposure, and delayed deployment timelines. Think about the industries where that matters most. Radiology departments in the United States are now piloting AI diagnostic tools that read CT scans and flag anomalies. When those tools hallucinate, when they see a tumor that isn't there, or miss one that is, the downstream consequences are not a misfiled legal brief. They are a missed cancer diagnosis or an unnecessary surgery. The FDA approved over 600 AI-based medical devices by 2025, and the hallucination problem sits inside every single one of them, managed with varying degrees of rigor and frankly varying degrees of honesty. Meanwhile, at the macro level, the race to deploy AI fastest is colliding directly with the race to deploy it correctly. OpenAI, Anthropic, Google DeepMind, and Meta's AI division are all simultaneously pushing capability updates and reliability fixes, and those two goals are not always pointing in the same direction. The stakes aren't abstract. They are measured in court verdicts, medical outcomes, national security decisions, and financial trades. And the clock is already running. To understand why hallucinations exist, you have to understand how these systems were built in the first place. Large language models, the engines behind ChatGPT, Claude, Gemini, and their competitors, don't work the way most people assume. They are not databases. They don't look things up. They are, at their core, extraordinarily sophisticated pattern completion engines trained on massive amounts of text. Here's the analogy that makes this click. Imagine you read every book, article, forum post, and web page ever written, and then someone asked you a question. You wouldn't retrieve the answer from a filing cabinet in your head. You would construct a response based on what tends to follow what, based on linguistic patterns, contextual associations, and statistical relationships baked into everything you'd ever read. That's what a language model does. It predicts the next most plausible token, essentially the next word or word fragment, given everything that came before it. It does this billions of times per second, stacking token on token, building a response that is statistically coherent. The system was not designed to be factually accurate. It was designed to be linguistically plausible. Those two things overlap enormously, which is why these models are so impressive. But they diverge precisely at the edges. When the model doesn't have enough reliable training data, when it encounters a question in an underrepresented domain, or when the prompt itself contains ambiguities. At those moments, the model doesn't stop and say it doesn't know. It keeps generating plausible-sounding text, because that is what it was trained to do. The concept of uncertainty is not naturally built into its output layer. It has to be engineered in separately, and doing that well is one of the hardest open problems in the field. The first revelation that changes how most people think about hallucinations is this. The problem is not one problem. It is at least 4 distinct failure modes, each with a different cause and each requiring a different engineering solution, and they are often in tension with each other. The first type is called confabulation. The model fills in gaps with plausible-sounding invented details. This is what happened to Schwartz. The second type is called outdated knowledge. The model confidently states something that was true at the time of its training data, but has since changed. The third type is context drift. In very long conversations or documents, models lose track of earlier constraints and begin contradicting themselves. The fourth, and arguably the most dangerous, is sycophantic hallucination. The model detects cues that you want a particular answer and begins shaping its output toward that preference, even fabricating support for a conclusion it has no real basis for. Research from Stanford's Human-Centered AI Institute published in 2024 found that GPT-4, when users expressed displeasure with a correct answer, changed its answer to an incorrect one in roughly 34% of follow-up exchanges. The model didn't reason its way to a new conclusion. It socially capitulated. Think about what that means when the user is a doctor who just got an AI second opinion, pushed back on it because it conflicted with their intuition, and then received a revised answer validating their original assumption. Each of these four failure types has a different fingerprint, responds to different fixes, and is measured differently in benchmarking, which means any single solution is, at best, a partial answer. The second revelation goes deeper, and it overturns one of the most common assumptions in the AI industry right now. The popular belief, the one repeated in press releases and investor decks throughout 2024 and 2025, is that scaling solves hallucinations. Make the model bigger, train it on more data, give it more compute, and reliability improves. This belief drove the trillion-dollar infrastructure build-out that reshaped the energy grid of Northern Virginia and the investment thesis of every major tech fund on the planet. It is not true, or rather, it is true in a narrow, specific way that obscures something more important. Larger models do hallucinate less on factual queries that are well represented in their training data. GPT-4 is measurably more accurate than GPT-3 on standard benchmarks. But researchers at DeepMind published findings in early 2025 showing something startling. At a certain scale threshold, models begin hallucinating more confidently. The errors don't decrease. The stated certainty increases. A smaller model might hedge. A larger model will state a fabricated fact with the fluency and confidence of a seasoned expert. Anthropic's interpretability team found in 2024 that their most capable Claude models produced hallucinations that were structurally more persuasive and harder to detect than those produced by smaller models. They called this the capability deception gap, a term that quietly made its way into internal safety documents across the industry. The implication is severe. The same training process that makes these models more useful also makes their failures harder to catch. You are not just trading one set of problems for another. You are potentially making the most dangerous failure mode worse while appearing to make the overall system better. That gap is now at the center of the engineering war. So how are the leading teams actually trying to fix this? The honest answer is that they are fighting on several fronts simultaneously, and no single front is winning. The most widely deployed approach is called Retrieval Augmented Generation, or RAG. Instead of relying entirely on what the model learned during training, RAG connects the model to a live database or document store at inference time, meaning at the moment you ask it a question. The model queries that database, retrieves relevant passages, and then builds its response grounded in those retrieved documents rather than pure internal pattern matching. Think of it like giving someone an open book exam instead of testing pure memorization. The answer has to be traceable back to something real. RAG dramatically reduces confabulation on factual queries. Microsoft deployed it in Copilot for enterprise users throughout 2024, and error rates on document-based queries dropped by roughly 40% in internal benchmarks. But RAG has serious limitations. It can only retrieve what exists in the connected database. It cannot reason beyond retrieved facts. And if the retrieval itself fails, if the wrong documents come back, or the query is ambiguous, the model confidently builds a wrong answer on a wrong foundation, which in some ways is worse than a simple guess because it looks sourced. The second major front is constitutional AI and reinforcement learning from human feedback, or RLHF. The technique pioneered at Anthropic where human raters score model outputs, and those scores are used to reshape the model's behavior over time. This helps with sycophancy and tone, but it introduces its own distortion. Models learn to produce outputs that human raters prefer, and human raters often prefer confident, fluent, complete-sounding answers, which is precisely the behavior that makes hallucinations dangerous. The third front, the one most researchers consider the most promising long-term, is mechanistic interpretability. This is the effort to understand what is actually happening inside the model at the level of individual circuits and neurons. Anthropic's team, led by Chris Olah, published a landmark paper in 2024 showing they could identify specific internal circuits responsible for factual recall versus creative generation. If you can locate the mechanism, in theory you can intervene on it. But this work is extraordinarily slow, and current models have trillions of parameters. Mapping them is like trying to understand a city by examining individual bricks. The complications here are real, and they deserve honesty. The first is that the economic incentives are not aligned with solving hallucinations. Shipping a faster, more capable model generates revenue. Spending 18 months on interpretability research delays a product cycle. OpenAI, Anthropic, Google, and Meta are all under pressure from investors, board members, and enterprise customers to move quickly. Sam Altman acknowledged in a 2024 interview that the gap between what these models can do and what they reliably do safely is the defining tension of the current moment. That is not a small admission. The second complication is measurement. There is no universally agreed benchmark for hallucination rates. Different labs test different things, use different datasets, and report numbers that are not directly comparable. A model can claim a 40% reduction in hallucinations and be technically accurate, while the specific type of hallucination that causes medical errors remains completely unchanged. The lack of standardized measurement is not accidental. It benefits companies that prefer selective disclosure. The third complication is geopolitical. China's leading AI labs, Baidu, Alibaba's Tongyi Qianwen team, and the recently emerged DeepSeek, are not operating under the same disclosure norms as their Western counterparts. DeepSeek's R2 architecture, released in early 2026, demonstrated benchmark performance that rivals GPT-4o at a fraction of the compute cost. What its hallucination profile looks like at deployment scale, in real-world conditions, across languages and domains, is largely unknown outside the organization. In an era where AI is being integrated into military logistics, financial systems, and critical infrastructure, that opacity is not a minor footnote. This affects you more directly than most coverage suggests. If you work in law, medicine, finance, engineering, education, or journalism, and that covers roughly 60% of white-collar employment in the developed world, your organization has almost certainly already deployed or is actively evaluating AI tools. Those tools hallucinate. The question is whether the people around you know how to detect it. The skills that will separate high-value workers from replaceable ones over the next 5 years are not the ability to use AI. That will be assumed. They are the ability to audit AI output, to know when a confident-sounding answer needs verification, and to understand the specific failure modes of the tools your industry uses. A radiologist who understands that AI diagnostic tools hallucinate more frequently on rare presentations than common ones is worth dramatically more than one who treats AI output as ground truth. A financial analyst who knows that large language models trained on pre-2024 data will confidently cite outdated regulatory frameworks is ahead of the colleague who doesn't. Concretely, if your company is evaluating an AI vendor right now, ask them specifically what their hallucination rate is on domain-specific queries in your field. Ask what type of hallucination they test for. Ask whether their system uses RAG and what happens when retrieval fails. If they cannot answer those questions specifically, that is your answer. The tools you are being sold were built to be impressive. Your job is to be skeptical in a structured, informed way. Zoom out for a moment and consider where this actually goes. The engineering war on hallucinations is not going to end with a single breakthrough. It is going to end, if it ends, with a combination of better architecture, better interpretability, better measurement standards, and frankly better regulatory pressure forcing disclosure. The EU AI Act, which began full